Alright, hello and welcome to Advent of Code Day 3. Since yesterday I've tidied up my main. As you see, I've now just got two functions here, day 1, day 2, and I've moved the logic into two different files. So here's all the day 1 logic and here's all the day 2 logic. So I've just tidied that up. I'm only going to keep the part 2 of each day in the code, because really part 2 builds up on part 1, so there's not really any reason to keep the part 1 code around. So let's have a look at part day 3. So what does this say? The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, which is going to be our puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. Right, so this is going to be decoding binary numbers, it looks like. You need to use the binary numbers in the diagnostic report to generate two new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position. The most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, so we're going to get a list of binary numbers, considering only the first bit of each number, which, when it says first, does it mean, because usually you read binary numbers from right to left, so does it mean this, the rightmost column is the first or the leftmost? There are 5 bits. There are 5 0 bits, so let's have a look. 1, 2, 3, 4, 5, 6, 7. And then the leftmost, 1, 2, 3, 4, 5. Yeah, so it's referring to the rightmost column when it says first bit. Since the most common bit is 1, the first bit of the gamma. So there's more 1s than 0s in... Wait, there are 5 0 bits. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Oh, it is referring to the leftmost column. First bit of each number. So there's more 1s in the first column than there are 0s. So that means the first column of our gamma rate is going to be equal to 1. Otherwise, if there were more 0s than 1s, then the first column of the gamma rate is going to be a 0. What happens when there's an equal number? How many rows are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are an even number of rows, so there could be an equal number of 1s and 0s. Unless in our puzzle input is designed in such a way that there's never an equal number. So the gamma rate is a binary number 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit. Look. The epsilon rate is just the inverse of the gamma rate. It's just if you apply a not, basically if you put this through a not gate, so 1s become 0s, 0s becomes 1s, you get the epsilon rate. So we only have to compute the epsilon rate once, and then we only have to compute the gamma rate once, and then the epsilon rate can be calculated very easily. And then the answer is just multiplying the gamma by the epsilon. So I did actually read this earlier today, and I did a quick mock-up of how this would work. So I already have an idea of how I can achieve this, but what I'm going to do is I'm going to copy the example. It should be easier for me to work with the example provided here than the full puzzle input, just to validate that I'm correct. So let's come back to here. So we're going to need to create our input file, which is going to be input day3.txt. I'm going to save that. I'm going to open that here, and I'm going to create a new file called day3.c. So this has 12, so define day3 max input has 12 rows. So as usual, we're going to do read day3 input. This is going to take our file name, and we want to construct, I'm curious, with our puzzle input, each of these is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ah, so I thought these would be bytes. But these have 12 bits in them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to say bits per line is 12. Although with our example, there's actually just 5 bits per line. So we can't use. I was just going to use a buffer of char, which is a 8-bit value, a byte. But I guess for now, I'm actually going to define. No, I will just use like unsigned int buffer. So these are our values. So this is actually going to be the exact same logic as our read day1 input, where we just convert. Oh no, it won't be. And this is interesting. We need to convert. We need to convert this string binary into an actual number. Like, I feel like it's going to be easier. Let me just create a void day3 here. And then if I open my main.c and just call day3, and we'll include day3 here. Right. Let's go back to day3. So given a number, say, given a value, say our value 64, what we want to do is convert integer to string binary representation. And the way we can do that is if we were to create a mask, I'll explain what I mean, but say I create this number 1. In binary, that's going to be, and I'll just use 5 bits for now, 1, 2, 3, 4, 5. That's going to give us, if this number 1 is this in binary. Now, if we were to do value and mask, so this operator here does a bitwise and. So we know 64 is, so this is the 1's position, this is the 2's position, this is the 4's position, 8, and this is the 16, so let's not do 64, let's do 8. So 8 will look like this. So when we do value and mask, that's going to and each of these. So in each column is going to look, and if there's ones in each value in that same column, it's going to spit out a 1, otherwise it spits out a 0. So this is going to say 0, and so we can use this to check what value is in each column. Because then our next mask we can do 1 0 and check if there's a 1 in here, then 1 0 0, and then eventually we get to the same as our value, and the mask will then spit out a 1. So the way we do that is I will do a for loop, which we'll just call unsigned int mask, starts off as 1, and then we sort of want to shift our mask by 1 each time. So what this operator does is in each loop it's going to do what I just there, where it starts off as 0 0 1. This is the left shift operator, so that's going to convert this number to, it's going to shift that one bit to the left. But that's going to read this out from right to left, and because we're constructing a string, we actually want to do this in the opposite direction. We want to start off with a 1 on the left side and shift it rightwards. So our mask actually needs to be it actually needs to be the max number, which is day 3 bits. So it's 2 to the power of day 3 bits per line. So it's actually pow. I can't remember. I always forget what the pow, how to do powers in C. Oh, I've just closed admin on code. Let's look. Pow. I don't want standard pow. I want C. I guess it has to be a float or a double. Can you do like a C integer pow? Oh yeah, of course. So so it's actually just 1 by day 3 bits per line. And then we need to come up with when to stop the loop. So basically, as long as our mask does not equal 0. Let me put that there. So if we were to just do this, printf I'll just do this on a new line. I want to print on mask. Let me get rid of these. And then let me just printf up here. This is day 3. Let's build it. So he starts off at 32, 16, 8, 4, 2, 1. So to So then we have to go through and concatenate a string. So we'll have our char, this is our binary string. It's going to be 9 characters long. Do you know, it's going to be day3 bits per line plus 1 for the terminator. So our binary string 0 is going to equal \0, that's our terminating character. And then we're going to use, I've got this prepared, no I don't, I think stircat. I'm going to concatenate to our destination, so it's just stircat appends a copy of the null terminated string pointed by source to the end of the null pointed string pointed by dest. Stircat so I'm going to do stircat our binary string, and then we want to generate, so basically if our mask and our value is equal to 1, then we put in a 1, otherwise we put in a 0. So this is a ternary operator, so it's just a shorter way to do if, and then this will just be string, and this will be our binary string. So if I do that, build it, let me just double check that our printf %d is printing our mask properly, which should be. And our value is equal to 8. What happens if I just do like 8 and 8? What does that print? It prints 8. So we want does not equal 0. If it doesn't equal 0, then we're going to print the binary string. So there we go. So you can see down here, it's printing our binary string. So we kind of want to do the inverse process of this. So given a string, char, given our our binary is going to equal let's do 00101, that should equal 9, and then that, and the null terminator. So let me get rid of this line. What's wrong with that? Oh, can't I assign it like this? let's just say binary string 0 equals 0. One, two, three, four. So we're going to do 1. So that should give us 9. Do we not just want that then? There we go. No. Sorry. Let me just comment. Oops. Oh, it was this. So there's that. Get rid of that. So we do want like +1. Well, like this becomes that, right? So if I did, yeah. So this is now our string representation. So we want to do the same thing. So for I don't know, int the index, we start off at 0 while the index is less than day 3 bits per line. We're going to do index ++, and then basically we set up our value. So our value starts off as 0, and then what we'll do is if binary string equals 1, or that's a character, if it equals the 1 character, then we're going to say value equals value or one. Yeah, we're gonna have to build it from left to right. No, right to left. So we're gonna all 1 and then value equals value shifted by 1. And then if it's equal to 0, we just shift by 1. So this can actually go here. So if we now do printf %d value, prints 18. Why does that print 8? That's 1, 2, 4, 8. Oh, it's doing it inverse. It's reading it. Oh yeah, if you were to read it backwards, it would be 18. So does this mean I need to do it the inverse? So shift it right, which means we have to actually do 1 like this. Why is that still 18? Build it. Interesting. This isn't working how I expected. No, of course that wouldn't work. Like, if the binary string is equal to let me make it explicit. And if we go up to that, that's probably gonna break. What am I doing wrong here? I guess because it's like a little endian, big endian thing, isn't it? I guess because I'm constructing this backwards. Yeah, I think it's just because I'm constructing this backwards. Let me bring this back. So let me get rid of this. So our value is equal to 8. It's going to convert it to a string and then try and convert it back. And then we set the value to 0. But we should be able to get that value back from the binary string. Yeah. So if I set this to 9. Hello. See, that works. So there's something very wrong with this. I'm just going to say sub value because this is still a working. So for each step of the value, zero, 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 and then 2. I think it does have to be less than or equals to because we're not reading this one. Now it's a 6. That should be 3. I'm doing something very wrong here. We're going to say add 0, good old print string debugging, or add 1. So our string is 4 zeros and then 2 ones. 1, 2, 3, 4, 5, 6. I've noticed it's actually constructing. Let me try something here. It might be that I'm doing this all wrong. One, 2, 3, 4, 5, 6. It's still giving me 1, 2, 3, 4, 5, 6. I should be only getting a 5 character long thing, in which case does this have to be -1? So we get a 3 long now we've got a 5 long string, 5 characters long. Add 0, add 0, add 0, add 1, add 1. So it's ORing 1 into the value and then shifting that to the right. If we then copy paste this again, our binary string 0 should equal the null terminator again, because that will just null it. Yeah, look, it shifted the whole thing. So this shouldn't be equals. Again, does that have to be -1? And then it's not reading the last one. It's like it's shifting it one too many times, which doesn't make sense to me, you know. RDX does not equal day 3 bits -1. Why is it doing that last shift? Oh, it's doing the last shift here. You know what? I'm gonna get rid of that line. Get rid of this else. Right. And then here we'll just say if IDX does not equal day 3 bits -1, then we shift it. There we go. So let me clean this up. So now if I change this to say 9, compile it, run it, so it's we can now freely convert back and forth. So let's split this into our functions. So this we want string to binary, but I actually prefer saying binary from string. Convert it, and void string from binary. So binary from string is, or string from binary is this. So it takes in a char star binary string, and it returns the binary string. So it returns the char star. And of course we also need to pass in our value. And then our so you see we do we're using this multiple times in 2 places, so I'm actually going to pull this out into a define. Free binary end is that we go. And then we'll take you, put this binary from string, this will return an unsigned int, and it will take a char star our binary string. Actually, it doesn't get duplicated, it's this bit that's duplicated. So it's just this. So this becomes 1 shift, and then this becomes binary end. So there's our 2 functions. Let me just click you. So now here's our value. And we can do printf, so value %d is %s in binary, and then we can say value, and we want binary, no, we want string from binary, and then we pass in our value, and we also need to pass in a binary string, which we've got up here. And then we just need to remember to say binary string 0 is always our terminator. So let me get rid of all this. So if when I compile this, where yeah, unsigned in value equals 0, and then we need to return that value. So value why is that? Wait, what? That should say value 9. What's going on there? Sorry, bear with me a second. I'm confused as to why that is setting value to 0. String from binary. This is modifying my value. Yeah, I bet you if I introduce another unsigned in here, it's now 9. So this is actually overwriting some memory. What's going on here? It's probably stircat. Yeah, it does have to be +1. Yeah, we do need the extra character in there to handle the null terminator. My bad. Let me get rid of this just to validate that works. Right. Let's do this. So let me open day 1. So we're just going to copy paste some of this. Copy that, paste it in here. This is going to return a bool. So our line now just becomes binary from string, and our string is our line. So then this becomes read day 3 input. Our file name is going to be input day3.txt, and we're going to give it our list of values. So we're going to create an array of unsigned int called values, and it's going to have day 3 max input. So let me get rid of all this. So if we did read the input, then for int idx equals 0, idx is less than day 3 max input, idx plus plus, we're going to do printf. We're going to print the number, new line, and it's going to be values idx. And we're going to compile and run it. And here we go. We should get, if I open our day 3 input, we should get 12 numbers. Let's validate that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep. So the first one, 1, 2, 4, that's correct. This should be 16 plus 8 plus 4 plus 2, which is 30. The penultimate one should be 2. Yeah. So that works. Now let's come back here. So if we remind ourselves, we need to count what's the most common, whether 0s or 1s are more common in each column, and if 1s are more common, then the first bit of the gamma rate. Okay, I think I get it. So we're going to do, this is going to return an unsigned int, and it's going to be day3 compute gamma and epsilon. It's going to take our unsigned int array of values, so we're going to have an unsigned int gamma rate, starts off as 0, and an unsigned int epsilon rate, which is also equal to 0. So how we're going to do this, we're going to generate our mask, same way we did our mask here. So we can actually copy this, so to validate that this is working, %s, we're going to do string from binary, and we're going to pass in our mask and our binary string here. So our char binary string is going to be +1. And now that we're using, oh no, we've only used this once so far, haven't we? Yeah. I'm going to get rid of you, and this is just going to be day3 compute gamma epsilon, and we pass in our values. And for now we return 0. Right, so let's compile this, run it. So you'll notice it's generating a mask in the first column, second column, third, fourth, fifth. So our mask generation works. So then what we want to do is loop through all our values. So for int idx equals 0, idx is less than day3 max input idx plus. And basically we want to check if it's a 1, and that's very easy to do. We just do a values idx and our mask does not equal 0. So this evaluates to true if there's a 1 in that column. So we basically want to have our ones count. This also is going to be an unsigned int, and if it is, we're going to do a ones count. We're going to increment that. And then we need to check basically if the number of ones, our ones count, is greater than half the number of lines. Because if it's greater than half the number of lines, we know that's the most common digit. So that would then be day3 max input divided by 2. And if that's true, we're going to take our gamma rate and make that equal to gamma rate, and the same as before, we'll OR1 shift 1. Again, we need to build build the gamma rate from right to left. So by the time we're done, this 1 is going to be in the leftmost column. So let's do this by hand then. So we know 1, 2, 3, 4, 5. Wait, 1, 2, 3. So how many ones? 1, 2, 3, 4, 5, 6, 7. So that's above 6. There's 12 rows. That's above 6. So how many ones in here? 1, 2, 3, 4. So the second column should be a 0. There's 1, 2, 3, 4, 5, 6, 7, 8. So the third column should be a 1. 1, 2, 3, 4, 5, 6, 7. So the fourth column should be a 1, and there's 1, 2, 3, 4, 5. That's less than 6. So our answer should be this. So printf gamma rate, well, our gamma rate should be that, equals, and then we're going to pass in that, and we're going to do string from binary, gamma rate binary string. So this line can go because we know the mask works. So obviously not working yet because we're getting 0, 0, 0. Our gamma rate equals gamma rate or 1, and then you shift it to the right. No, sorry, this is the wrong way round. It should be 1 and then or. It should be shift then or. Nope, still not working. That means our ones count. Let me print our ones count. Make sure that's working correctly. Seven, 5, 8, 7, 5. So that would produce oh look, our gamma rates are different now. So 7, 5, that would be 1, 0, 1, 1, 0, which is 1, 0, 1, 1, 0. Let me just again print f, add 1. So let's compile that. Sorry. Print a new line. 1, 1, 1, 1. So it looks like our shift to the left isn't working. Of course. We need to shift. So gamma rate has to always shift. And then we can actually, I think we can do an ORs equals here. There we go. Yeah. We weren't having the case for when the zeros count is greater. Okay, so let me get rid of these debug lines. So now we know that our epsilon rate is actually just equal to the inverse of the gamma rate. So let me get that, copy paste this. So our epsilon rate is just that. So when we print this, we should see that the epsilon rate is the inverse of the gamma rate. So where there's a 1, there's a 0, and vice versa, which is what we see. And then the result is just the gamma rate multiplied by the epsilon rate, like so. So unsigned int result equals this, and then print f day 3 gamma times epsilon equals percentage d. Now, what I don't know is if, let me compile, gamma, oh, forgot my new line, negative 506, that doesn't seem right to me. Because these are all unsigned. Let me do percentage d comma and percentage d comma. So I just want to also see the numerical representation. Epsilon rate negative 23, even though it's unsigned. Let me oh, is that because it's more of a representation thing, isn't it? A formatting thing. Yeah. It's because I'm using percentage D. I actually need to do percentage U for printing unsigned numbers. Okay. So does this expect the number? Be sure to represent your answer in decimal, not binary. Okay. So I see what's happening. So the gamma rate 22 is correct, but the epsilon rate is massive. And the reason is we're using the integer, which is usually 4 bytes long, so that's 8 times 4. But we're only using a subset of them. So when we do the complement, the inverse, it's setting all those zeros. We're not using to 1. So we also need to create a mask to mask that out, which is basically like size of becomes size of unsigned int minus the day free bits per line. So we actually need our epsilon mask equals 0 for int we want to do this is going to be our unsigned int. We want to do epsilon mask equals epsilon mask shift 1 or 1, and then it basically becomes the inverse of the gamma rate and the epsilon mask. Let me see if that works. That doesn't work. Let me just do a printf size of percentage u let me comment this out. I just want to for so it's doing it in bytes, not bits. So we want size of times 8. So let me copy that. I want to see what the size of this is. $27. Let's validate that. So an integer is 32 bytes minus 5, 27. So that should fill it with 27 ones. No, I'm doing this the wrong way around. We just want to do this, bits per line, and then shift it right. Yeah. Let me get rid of this line. Let me printf epsilon mask percentage s, and then I want string from binary. I want the epsilon mask, and I want the binary string. Oh, sorry, why have we got two ors there? There we go. So our gamma rate is 22 and our absolute rate is 9. That should match up with the example. Yep. Which produces the power consumption. 198. 198. So this should actually be compute power consumption. Power consumption is, let me get rid of this mask now. And then compile. Yep, so time for our puzzle input. I'm going to copy this. Get rid of all that. Paste it. So we can see there's 1,000 entries. And there's 12 bits per line. Let me just validate that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, compile, run. There we go. Power consumption is 741,950. Moment of truth. That's the right answer. Okay, so that took us an hour. Damn. Okay, part 2. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your and consider just the first bit. Oh god. Right. Keep only numbers selected by the bit criteria for the type of rating. Discard numbers. If you only have one number left, stop. This is the rating value for which you otherwise repeat the process. To find oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1 in the position being considered. Both the oxygen consider just the first bit. So when it says discard numbers, I'm going to assume it means discard the entire line, which do not match the bit criteria. Got you. Does it give us an example? So let's just do this. So it looks like for that first criteria, 0, look, there's 3 zeros and 2 ones. So 0 is the most common value. So it wants us to get rid of any numbers that have a 1 in them. And then in the case that, I mean, it doesn't look here because I've got an odd number of lines here, but in the case that it's even, then we just keep on ones. That makes sense. Let me head back. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process, considering the next bit to the right. So the CO2 scrubber rating determine the least common value in the current position and keep only numbers with that bit in that position. So I'm going to have to like keep track of two different filtered lists, one for the oxygen, one for the CO2. For example, to determine the oxygen generator rating value using the same, start with all 12 numbers and consider only the first bit. Multiply the oxygen generator rating by the CO2 scrubber rating, and that gives us the life support. Right. Okay, let's do this. So unsigned int day 3 compute life support, and this is going to take in our unsigned int values. Okay, so first of all, we're actually going to not only need values, but we're going to need our two lists, which is going to be our oxygen list, which is going to have our day 3 max input, and our unsigned int, our CO2 list, we're also going to need our oxygen list count and our CO2 list count. Here. So we're going to do kind of the same thing. I'm going to just copy you for now, where we generate our mask, and then we do our ones count. And then we need to check if our ones count is greater than our day 3 max input divided by 2. If it's greater than or equal to, so now, because that will also supply the case for when there's an equal number of zeros and ones. Then we check if if the first bit is a 1, we keep it. We put it into our oxygen list. And the way we do that is we then have to loop over all our values again. We need our you basically need to do the same logic, right? So if it's equal to 1, then we add it to our oxygen list. So our oxygen list count equals our values IDX. Else, if it's a 0, then basically, if it is a 0, we add it to our oxygen. Now there's probably a way to collapse, yeah. So what I'm going to do is have our bool call this collect ones equals this, and then I'm going to extract you, and then I'm going to have a bool is 1 that becomes you, and then this basically becomes if collect ones and is 1, or not collect ones and not is 1. There's probably a more, you could probably make this more efficient, but I think this is just a bit more readable. And then all this can go. So now we have our oxygen list. And then our CO2 list kind of just becomes the inverse, right? Which is if not collect ones and is 1, or collect ones and not is 1, then our CO2 list equals values IDX. But this then doesn't yeah. So actually what we want to do is put this in the loop. If that makes sense. Because it's then we go on to the, so we're shortening the list each time. And the way I think I can do that is, actually we do want to pass in our oxygen list and unsigned int CO2 list. So this actually just becomes oxygen list and our CO2 list. We could just do like a mem copy, couldn't we? But it's a number of bytes to copy. What is it? Source dest? No, it's dest source. So in the copy values, it's going to be the size of unsigned int times the free max input. And then we're going to do day free compute life support oxygen list and CO2 list. Life support is this. That's values. So we have our oxygen list. This is really interesting. What's the best way to do this? Bit criteria. Okay, what I'm going to do is only consider one list. So we'll call this values again. Criteria. And then it's just going to be bool is oxygen. Because there's only two criteria. So that means we'll keep our collect list here and our collect list count here. This goes. So this is just going to be our. We're just worrying about oxygen for now. Our collect list. Collect list. Count. Once we've collected that list, we then need to basically iterate on it. So our our collect list count actually starts off with day 3 max input. So once we've done all that, we're actually going to do mem copy. And we're going to copy into values the collect list size of unsigned int times our collect list count. Are we missing a, yeah. Let me just, for now, return 0. So this becomes our collect list count. And then we basically say if collect list count is equal to 1, so there's only 1 left, we're gonna break out of this loop. And then actually we're just going to return the first value. Is there a case where I think there should always be a case where there's just 1 number left. So we loop through all that. If it's the ones, then again, this becomes our collect list count. This becomes our collect list count. And then this just becomes our oxygen list. True. And actually, I'll do this in here. It's going to copy values into the collect list to begin with, and that way I don't have to do that here. So let's have a look. Compile that. Printf collect list count is %u collect list count. I just want to see how many are left. Collect count is 0. And let me oh, and then we need to we want a different count, a values count, and our collect list count is 0. So values count so this becomes values count values count, and then when we're doing the mem copy, we're going to say values count equals collect list count, and then collect list count we reset back to 0. And then I'm just going to say values count is equal to values count. So I want to see that lowering. So we copy our collect list count, and then basically if our values count is equal to 1, we break. And 1000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let me get the example code. Paste that in there, and then we need to set this back to 12 and 5. So F1, F2. So what did the example say? There are an equal number of 0 and 1 bits, so to finally keep the number 1, start with all 12 numbers and consider only the first bit of each number. There are more. Discard the numbers that don't have the bit criteria. So that's sort of what I am doing here is so the first time we do this, we're checking the first bit, we're counting how many ones, we're counting ones in that column, and then we discard number if no criteria match. Right, so our collect ones, if our ones was the most common, and that value is a 1, then we add it to our collect list. Collect, this is false if our zeros are the most common. So if it is false and it is a 0, we also add it to our collect list. We then copy the collect list back into our values array, but we only copy, and then our values count just becomes our collect list count, and we reset the collect list count. This should be values. Life support is 30. Oh, the oxygen. The oxygen generator rating is 1011 or 23 in decimal. So let's do some printing, print time to validate this. So if we collect it, what I want to do is printf I'm going to print the mask and the value as binary. No, I'm going to print the value as binary. And this is going to have like 1, 2, 3, and then it's going to have our binary string from binary. We're going to do values idx and our binary string, which we don't have yet. So I'll do that here. Char binary string is our day 3 bits per line plus 1. And then I'm gonna copy paste this, and I'm gonna do our mask as well, which is gonna be our mask. So if I now do this and run it. So our first mask 1, so that gives us so let me just come back to here. Start with all 12 numbers. So we'll keep only the 7 numbers with 1 in the first position. So we should only see numbers with 1, and that should be 7. 1, 2, 3, 4, 5, 6, 7. So that's working. And you can see values counting 7. And then if we come back, then consider the second bit of the 7 remaining numbers. There are 0. There are more 0 bits than 1 bits, 4 to 3. So only keep the 4 numbers with a 0 in the second position. Notice it's only keeping So we can see here, if we did printf I want to know if the small ones or more zeros. So so it says here the small ones. It just always says more ones. And that's because our ones count. This is always returning true. right? Like if I did just percentage %u here and just did ones count, it's always returning the same. Yeah. Why is that? Because that was working here. And mask. D3 binary. Mask does not shift to the right. Let me print the result of the mask. Printf percentage %u of the mask result, and this is going to be this, right? Mask result 0016. Mask result 0080. So there's only 3 values that is not 0. So why is our ones count and our values count over 2? What's going on there? Seven, 1, 6. Why is our values count now? Values count is 7. And half of 7 is 3.5. Do I have to do something like this? Just add 1 to it to account for when we have a odd or even number. 3, 4, more zeros, more ones. Life support is 23. 23. So yeah, because of the way I'm doing it, just dividing by 1. I should also really update this then, where I'm doing max input plus 1. There we go. Okay. Let me delete that line, that line, that line. And delete that. Delete. Keep this for now. So here we go. So our mask is this, so we select the first row, and then our values count is now 7. We select the second row, values count is now 4. Third row, values count until eventually we're left with 1 number left, and that's 23. So we now need to do what I don't want to do is modify I'm going to call this inValues, and I just want to create a new unsigned int values, and I'm going to memcopy values to inValues. So that way we're only modifying get rid of that. This, and we're not modifying the actual array because we need to reuse that for, so this is going to be unsigned int oxygen rating, and then our CO2 rating is going to be day free compute life support values false, and then our unsigned int life support rating is going to equal our oxygen rating times our CO2 rating, and that's going to be that, our life support rating. So we now need to use this is oxygen boolean, which is basically here. So if is oxygen, else basically want to flip these around. Let me paste this. Oxygen rating, CO2 rating, compile and run. So our oxygen rating is 23, CO2 rating is 10, life support is 230. Let's validate this. Yep, CO2 scrubber rating is 10, and you multiply them to get 230. So let's get our puzzle input. Let's delete this, save this. Remember, we now need to change this to there's 1012 bits. Okay, build it and run it. And here we go. Our oxygen rating is 282. Our CO2 rating is 3205, and our life support rating is 903,810. So let me copy that, paste you in here, submit. Right, answer. So we did day 3 in just under 2 hours. yeah, day 1 took me maybe about half an hour. Day 2 took me an hour. Day 3 took me 2 hours. I seem to be doubling how long each one takes. So maybe, hopefully day 4 doesn't take 4 hours. But we'll see. Wow. Let's look at what I've done here. So we created our 2 helper functions, binary from string, string from binary, to sort of easily convert between them. Our input logic is still pretty similar. And to be honest, because our day 3 input and our day 1 input, they're actually exactly the same except for this line here where I do A to I, and here I do binary from string. So I could probably factor these out into a file reading helper library and use what's called like a strategy pattern, where I actually pass in a function pointer here. We'll see if a future day, I think once I've got like another day where it's very similar, then I'll factor it out. But seeing as it's only 2 days where it's similar, it's not really worth the effort just yet. And then we had our power consumption, which is, you know, it's a fairly simple function, 56 to 85. It's about 30 lines long. All in all, our day 3 code is 158 lines long, which isn't too bad. And our life support function did a little bit of like, you know, messing around with memory and stuff. I'd probably factor these out into their own structures, and create like a helper sort of list object, well, list structure. So I can do less of this memcopy stuff, but it works. Cool. Until next time, take care. Bye.